For our project, our robot's main goal is to rescue victims from a fire that is, or it's to rescue victims from any type of emergency situation that could have happened on our Mars base. And our plan to rescue said victims is with an arm-mounted electromagnet that'll be able to transport specific victims by picking them up with um, built-in magnets in their suit. We're doing this because we need to be able to protect our workers and our scientists and any type of staff that we have on our base on Mars. And accidents can always happen and nothing will always go as planned, so we have to have safety precautions, and having a robot to help rescue people in danger is always a good thing. How we're going to do this is we're going to use a color sensor that'll be able to detect any of our employees that will be through the fire. And we're going to use a color sensor, and we're going to use a big claw to be able to grab the victims.
So as Mateo keeps clicking to go to the Python,
I'm just trying to reload the.
It pops up and then it disappears, and then whenever we put something on our platform to create our code, it just goes yellow because there's no start, like that.
So this is the code. So first thing it does is set both motors left and right to 20% power. Then the robot moves straight for 13 rotations of the wheels. Then the crane arm, which is motor C, rotates upward at 6% to 45 degrees. Then motor E turns on the motor E on 50, turns on the electromagnet motor E to pick up an object at 50% power. The magnet remains active for 1 second. Then motor C returns to original position of 0 degrees at 6% power used. Then the robot removes straight backwards at -20, so it's going reverse the original path, but in reverse for the same 13 rotations. Then the robot moves in a turning or angular path to adjust its position. The left motor runs at 30, or makes it 35 degrees, and the right motor runs for 2.5 seconds at 1% power. Creates a slight turning movement. Then the robot moves straight again at 20% power for 2 rotations, and the electromagnet is deactivated, releasing the object.
The robot drives forward in a straight line for 13 rotations of both motors, which the speeds are equal at 20. The first arm segment, motor C, lowers to a position of 45 degrees, and the program pauses for 1 second. The electromagnet E, which is motor E, turns on at a speed of 75, which right here you get a 1 second pause, possibly to allow the object to attach. Then it raises back, and the robot rotates in 13 rotation, and both motors in reverse. Then once it stops, it goes for a 1 second pause for the next movement. The robot moves backwards at a speed of -35 for a 0.1 second, and it's a short reverse moment. The robot performs a final second rotation turn to adjust its position and pick it up.
The robot had initial difficulties with precision and color detection and GPS navigation, especially when trying to differentiate between victims at high speed, magnetic pickup, was also challenging as it required precise alignment over the victim. We refined the line following algorithm to enhance accuracy by adding gyro-based stabilization, which helped the robot stay on track for color detection. We recalibrated the sensors to improve victim identification. Lastly, we added a delay in the pickup mechanism, allowing the robot time to positive correctly. We learned the importance of refining each component in a robotic system for effective teamwork, precise navigation, and timing, paired with advanced line following and resource differentiation are key for autonomous operations, especially in time-constrained environments like Mars. This project also highlighted how autonomous robots can support human operations by carrying out essential, repetitive, or hazardous tasks reliably.